the visual component that we use to build our interfaces. So this is the website that is used as a showcase for the library. Everything here is actually real. So there are, let me go back to the page. There are code example, instruction. It's mainly about forms because we use a lot of forms. And some Panda. Here we have a color system. We have a base for the palette that is made just of 6 colors. And then based on which primary color is selected, those are our brand primary color. And we can also switch from dark mode and light mode. And here there is all the derived palette. So changing those colors, you will see that some of those colors changed. This is the dark color, light, and the light color, and so on. We have also some example. For example, there is a credit card form. And you can see the code. Don't remember. Yeah, here you can see how this is made. What else we have here? Is a counter that we use in some of our application. This is simulate kind of a car counter. And I think this is all about the demo of our application. So let's go back to the presentation. So as I show you, some of those projects also work with our JavaScript. For this one, we use Elm Starter. That is a tool that we created that is also open source that helps to generate the website server side. Okay, some of the detail about the things that we like. So the guarantees are the most important objective things that we think are relevant in Elm. So those are like no runtime exception, 100% immutable data, 100% pure function, and all types are checked. So this is like, let's say, a condensed version of all the features that Elm has. So these one are what we consider the most important one. And what is also very important is that those guarantees apply to all dependencies. So they are not only about the code you write, it's also about all the library that you are loading into your code base. Other things that we like is that Elm is easy to learn. It's also used, like in this picture, by some school to teach programming to children. It is simple, but that doesn't mean that it cannot express complex things. It means that it has been designed with the idea of being friendly to beginners. And it also changed following this design principle. For example, before Elm was using signals, and Evan Czaplicki, the author of Elm, while teaching Elm during the meetups, realized that this concept was a bit difficult for beginners to grasp. So then he took the decision to actually remove it from the language itself. So now we don't have signal anymore and use different concepts. So this has several consequences. For example, now we have several engineers in an offshore team in China that they help us with Elm. So it was very fast for them to start doing modification in production. Another consequence is that we have back-end engineer now that they sometimes modify the front end by themselves without asking front-end engineer to do the work. And we even lately we even ask non-technical people to change the code, mainly for translation. So we have translation. They are hard-coded in some Elm file. So we give permission to copywriter and translator. So they go there They change the file and then they save it, and automatically they create a pull request. Another things that we like is how many things you don't need to do compare, for example, to JavaScript. You don't need to use a try catch block. You don't need to test if a method or a function exists that you do on JavaScript all the time to avoid errors. You don't need to test if a value is defined. You don't need to test if a value is of the right type. You don't need to learn truthiness, and you don't need to write type annotation. So there is a lot of stuff that we don't need to do using Elm, and I think this is also very, very good. About not using try-catch blocks, how this is possible. As an example, well, Elm doesn't throw errors. The way it does is basically he uses the type system for errors, and the compile makes sure that you handle them. So basically, yeah, it's just about leveraging the type system. Those are a couple examples that are a bit delicate if you use them in JavaScript. For example, JSON parse is one of those things that can fail in so many different ways. You can give it some JSON data that is different from what you expect, and this can break your code. Or you can even pass some broken JSON data to it, and it will simply crash your application. We will see about JSON parse more later. About local storage, lately we have an issue. Some user reported that our app was crashing. So when our app is crashing, we usually just look at the JavaScript code that fortunately is only around 3% of the entire code base, because Elm doesn't really crash. And then we realized that this user was disabling cookies in his browser. And so local storage became like undefined. So then you will get, you're calling a method for an undefined value. So then we add conditions. So we were checking if the local storage was defined. And then again, the app was not working, was still crashing. Then we realized that actually just the action of checking local storage was throwing an error. So then we have to wrap everything in a try-catch block. So those kind of experience, they never happen in if we work inside Elm. It's a nice thing. So unfortunately, local storage need to be used from outside Elm, so those things can still happen. It's also interesting to see how people that for some reason cannot or don't want to use Elm try to replicate the same experience somehow. For example, there is this library, Never Throw, that is a JavaScript library that uses the same concept of Elm, trying to bring the errors inside the type system. Another things that we added recently is Elm Review. The Elm compiler is already famous for being like an assistant. And as if this was not enough, now Helm has this very advanced static code analyzer that is not only reporting issue in your code, but is actually fixing them. So this is I tweet about this. The first time we run this code analyzer, it removed 1,200 lines of code. That was around the 3% at that time. So it was a bit scary, the first time we run this, but now we go used to it, and it never removed stuff that is important. And yeah, now we run all the time. Every time we create a new commit, first we run this one. There is another concept that I personally like very much about using purely functional languages. That is this idea of abstraction over the order of evaluation. I think this is, for me, play a big role in this feeling of joy and relaxation that I have when I write functional code. So basically, the order in which you write the code, it doesn't matter. So take this example. What do you think will happen if you run this code using JavaScript? Well, you will get a reference error because you're using B before it being defined. What happens if you run the same code in Elm or in other functional language? It doesn't matter. It just works. And this let you, to rearrange the code, move function into module, change the order, bring them back. Everything just keep working. So this is so nice also for refactoring, large refactoring. How is this possible? Well, if you have real immutability, it's quite simple. Basically, the compiler start from the main function, let's say C in this case, and then start the execution from there. And every time you need something, go and grasp it. So basically, it's the compiler that is putting everything in the right order for you at compile time. Another things that I think is nice of Elm is how it's influencing not only the front-end world, but the programming world in general. Those are a few concepts that I think have been very influential. One is the Elm architecture. I put there a list, I don't know, maybe some of them are not maintained anymore, but a list of library that implement similar things to the Elm architecture in many different languages. And also Redux and Swift UI are inspired by this Elm architecture. Then there are errors. Helpful and friendly errors are famous for Elm, and Rust and Scala were inspired by those to improve the error system. And then this idea of avoiding runtime errors. There is never throw, the library just show you, and then there is a Hegel that is an attempt to, similar to TypeScript, but even stricter, to type check JavaScript code to avoid the runtime errors. I sometimes get feedback from people that just do a quick search on Google or look at the Elm repository on GitHub, and they come to wrong conclusions. So let me clarify a few things here. So first of all, Elm is not really a normal open source project or a usual one. So in other words, Elm is not a list of features waiting to be implemented. So it's, as Evan liked to put it, if you like what you see now, that's pretty much what Elm is going to be for a while. And here for a while means like years. So basically, Elm as a language is pretty much done. And there are things that Evan now is working around that will come out, but the language itself, it's very stable. Sometimes there are concerns about the version. So Elm is now in version 0.19. And for me, more than a version number, what is important is the stability and the number of bugs that the product has. And Elm proved to be very stable and bug-free, more than other products that maybe they have much higher version number. Also, there is not really a strict rule about version progression. Here I put some example. React Native is version 0.65 after 6 years and 361 releases. React jumped from 0.14 to 15 version. And the Oracle database is famous for jumping from like beta to version 2. And the co-founder of Oracle, he says that, well, we knew no one would want to buy version 1, so let's just skip it. So I think there are a lot of psychological connotation attached to the version number. This is the history of Elm. So basically, the removal signals, the one I just mentioned, happen in in 2016. Since then, there have been two major other releases, and but basically none of those were that big. And then, yeah, so the last major release was in 2018. So now is what 2-3 years since the last major release. But that's how Elm works. Now everyone is working on those things: dense binary format, static binary format, static evaluation, primitive types. He recently posted updates about those investigation on discourse site of Elm. So when is the best time to start using Elm? Well, to me, it's like yesterday, or maybe five years ago. Maybe here was a bit difficult update. So yeah, maybe 5 years ago, May 2016 have been the best day to start using Elm. So one of the lessons learned in this year is that if you need to recommend someone or yourself how to evaluate Elm, I would recommend to join the Elm Slack community, or try to build a demo application, or watch some video on YouTube, Evan Chapliki or Richard Feldman or many others. Get a book of Elm, there are good books about it, or ask someone that already use Elm. But don't just Google it or go to the GitHub repo of Elm. Okay, so we are still working without JavaScript, CSS, and HTML in the front end, but we added contests. So let me explain. So the slide that you see in the middle is a proposition that I used when I started using Elm 3 years ago. So the idea was that we would replace JavaScript with Elm, and then we would replace CSS and HTML using Elm UI, that is a library. So the pro of this choice are that basically, you can write a web interface without struggling with those languages like JavaScript or CSS. Let me describe what is Elm UI in a nutshell. So CSS went a long way since its creation. So today we have grids, we have flex bosses. So we have a lot of nice stuff, but still it's a lot of trial and error when you use it. So Elm UI follow instead the principle of least astonishment. So what you write is what you get, like no surprises. For example, if you want to center something in the screen, this is the classical example, this is what you need to write. You just say, okay, center by X, center by Y, and then it goes center, okay? So this is what we have been using since the beginning, and we are very happy with it right now. All our projects use Elm UI, basically. Maybe not the 404 page, but everything else. But Elm UI, actually, as everything else in Elm, suffer from the fact that all parameters need to be passed function by function, because there is no concept of global values in Elm. Okay, so for example, if you have a theme that contain, for example, if the interface is in light mode or dark mode, and you need that on the last leaf of this tree structure, you need to pass node by node. Okay, so this can be a bit annoying. So if we look at the code, you see you have a lot of passing from view 1 to view 2, or from view 2 to view 3, and so on. So how can we improve this one? Because we end up with a lot of data that need to be passed over and over. So it would have been nice if we could do something like this. Okay, so we could make it, this looks like a global variable, but is it this possible using a language like Elm? Well, it seems it is. So there is this new library, Elm UI with context. that does the trick. So this is the code that you can get. So you see we don't pass the theme anymore, and wherever is needed, you bring it back using the function with context that accept a anonymous function. So yeah, this is how it works. So it's kind of magic. This is just to compare the two the two versions. How is this possible? Well, I don't know really. I think it's using a reader monad, but don't really ask me details about this. It's just a library and it just works. So, but if you're curious, you can look this up. We also run a regular internal workshop now in Rakuten, and as a consequence, we created several training material, and some of those are also available. I will show some of them. So one is this e-commerce website. Is 2,500 lines of Elm, 0 line of CSS, 25 lines of JavaScript, and 15 lines of HTML. Has those characteristics. Is responsive. Is a cart and fabrics management, persistent in a local storage, dark mode, and so on and so forth. Let me quickly show you a demo of this one. So this is the website. This you can also find open source. So you can select a product, add to the cart, put something in the favorite. They're down here. You can look them up. You can manage them. You can remove from the favorite, and they will disappear from down there. You can remove from the cart. You can change the number, and so on. So here we use all our best practices. So I think it's very good if you want to check the way we work. It also come out with the dashboard that is also written in Elm. That is this one. So from here you can test your application on different form factor. And this is live, so you can still interact with it, and you can code your application from this view as well if you prefer. And you can also change the size of the device. You can zoom in. You can change the width. You can also change this width of the application itself, change colors, and so on. And let me show you about, we will talk more later, but let me show a bit about JSON. So these are, for example, this is what is saved in the local storage, and you can edit live here. And you see that even if you break it like this, you get an error here, but the application is still up and running. But the application is keep reading this one. So for example, if I change dark to light, you can see I'm getting error because I didn't finish to write the word light. But as soon as I finish, then the application recognizes, oh, this is a valid data, so I will use it. The same things you can do with the response from the server. So this is the response that contains all the product. Again, you can try to do something. So maybe backend developer decided that this is now a string, it's not a number anymore. Or maybe, yeah, it's completely like a string like this. And then you can say, well, here, of course, you have a warning already because this is not what is expected, but you can say, send the data anyway. So let's simulate the fact that this data is actually going to the app. So you do this, and you can see that app now goes in an error state, but it's still working. It didn't crash. It just showed the error. And of course, if it was a real application, it would have probably a nicer error. But it's still trying to, to keep going. And then if you fix this one, then it will go back to be alive. And here you can do whatever you like. You can remove piece of stuff and send it anyway, and it will still be up and running. So this also it's available. We made some exercise. This one is we didn't put that many exercise after all, but I think the idea was interesting. So here you could edit your code, Elm code, and then you will compile it. And on this other side, you will see your result, and there are some tests that is not visible now. You have to pass those tests, and then we'll keep also the history of how many exercises you solved and so on. And then we have the cheat sheet that contain basically all you need to know about Elm, including advanced stuff and example. So I think it could be useful for a person who starts learning the language. Okay, next, let's talk about patterns. I think patterns are a very interesting concept, and I wish we learn earlier in time. So my recommendation is, if you're starting to use Elm, I suggest to have a look at this website as soon as possible. Let me show the website. So this is the website, very simple one. These are the patterns. They come with the example and anti-pattern pattern. So it's gold, really. We have several libraries that we built in the past, and they have, frankly speaking, have bad interfaces because we didn't spend enough time learning this stuff. So this is what help you to build also library interfaces. Some of the most famous patterns are this one, making possible state impossible, parse don't validate. We will see those. The railway pattern also, I will show something about it. So there is a lot of interesting stuff. Let me show some of them. Before proceeding, I don't know if you are familiar with the pipe operator. This is something that Elm has, and maybe JavaScript will also have in the future. So all these forms are the same. So here we call the function f4 with the number 42, and then whatever is the result to be passed to f3, and then the result will be passed to f2, and then to f1. You can write this way with the pipe on the left direction, or you can write this other way, that with the pipe reversed. So the second version, it basically has the advantage of that you don't need to close the parentheses. This one, it helps you to visualize how the data flow. So the 42 goes down here and go to through F4 and then F3, F2, F1. Those triangle, of course, they're usually built with those characters. They're not really triangle. So let me show you as an example some of those patterns. So for example, make impossible state impossible. This is a mantra in the Elm community. So the idea is, for example, let's suppose you have an HTTP request that you are monitoring. So this could be a way that you store the state of this HTTP request. For example, if it's fetching, this will be true. If it's access, this will be true. The payload is stored here, and maybe a string, but maybe there is nothing. So it's an optional value, and the same here. But if we calculated the cardinality of this record, it came out that has 16 possible state, because this could be, for example, true, nothing, nothing, false, true, nothing, nothing, and so on. You do all the combination, and it come out like as a 16. But in reality, there are no 16 possible state. So a better way to model this situation is to use a custom type, or an enums, if you want to call it like that. So the cardinality now is down to 4. That is exactly the number of states that are possible. So the idea is that we try to model the data to be sure that the impossible states are never possible to be stored in our application. So then the compiler will stop us for storing those. This is the idea of a parse don't validate. Let's suppose we have an input made by a user. So maybe the user typed the name, but maybe didn't type the name. So we will have a maybe string here, because maybe it doesn't contain anything. Or the same for the age. Maybe the user didn't type the age. So we may have a function that take this data and return a Boolean that says, yes, is this valid or is not valid. But after that, we still have this data that is encapsulated in this optional value. So a better approach would be instead creating another type alias that is a kind of interface in TypeScript, that instead the optional value has a strict value, like string and integer. And then we have a function that converts from the user input into a valid user. Of course, that may also fail in case the data is not correct. Another pattern is another concept is, of course, a function composition is important in functional programming. And then there is this idea of using the railway as a metaphor that I think is kind of fun. So here, for example, you have a function that may fail, and it can be represented like this. So if its success is green, if it fails is red. This is convert a string into an integer. So the idea is how can we compose all those functions together? Because looking at here, they cannot be attached. So one solution is to create stuff like this. And here I suggest to only look at this maybe. You can see this in this type of notation, those are similar. So it means that this can be somehow chained together. So we can use, and so we can connect like this. So it's pretty fun. Well, after you get used to this stuff, it's pretty fun. So for example, this is a way more complex function. But if you look at the type annotation, it has this similarity that this part are similar. So this one was something we wrote that is in the e-commerce example to chain updates together. So to make to take the update and to split in a smaller one. So something like this. So we have the main update that is now composed by a smaller update. Another thing is when you create like a smart function, try to look for in this search engine using the type annotation, and it may happen that you find that someone else already came out with your same idea and maybe also with the better implementation. So this is a search engine that works with the type annotation. It's pretty nice idea. If you're interested in railway-oriented programming, I recommend to watch video of Scott Flashin on YouTube. They're quite interesting. Okay, I'm running a bit out of time. Let me see. I want to skip something here. So about JSON, I already talked a bit. So maybe I will skip this part. Basically, what I want to say that, yeah, let me skip it to here. Basically, Elm is taking care of making sure that the parsing of a JSON data, it doesn't do any harm to your application. So what it asks you to do is to teach how to parse this data that it's like a string. So because it needs to convert the types that are in the JSON to the type that are in Elm. So for this one, you need the encoder and decoders. Depends in which direction you go. So encoder and decoders in Elm are not the simplest things, especially for for beginner. But there are a lot of tools. For example, this one is online and you can use it. You just paste some JSON structure and it will automatically create the type alias that you need and the decoder and an encoder for you. So it makes the process very simple. In our project, we also use OpenAPI to store the description of our API, and we can run a tool that will automatically convert it into Elm code. So all the encoders and decoders will be automatically generated. There is also a nice library, it's called Elm Codec, that you just create a codec and then will automatically create both encoders and decoders for you. So this simplifies a lot the work. And this process is pretty good. So we sometimes find issues in the backend because Elm is very accurate in finding errors if the data is not correct. One thing that we value a lot is also to be explicit when we write the code. There is this concept that we spend more time reading the code than writing it. So we don't mind if we write a bit of more like boilerplate. We don't want to, our colleagues making this face when they read our code, or even worse, when we read our own code, maybe a couple of months later. So we also try to write junior code. So this is an interesting concept that it's the idea of writing simple code. Let me go a bit faster here. So these are example of structure that we prefer to write, like in this situation, like with the case of, that is a bit more idiomatic, rather than using all those functions that may be not so intuitive to read. We also try to avoid the point-free style. That is this system of removing some argument from both here and here. We believe that this is more readable. Also, function composition, maybe this is not the best example, but this operator here, we try to write like this. It's a bit more explicit. This is more for people who are a bit familiar with Elm, but yeah, we try to keep our code clean. And after you learn how to write code in Elm, then when you write JavaScript, also your style, it changes. For example, if you see JavaScript written like this way, there is always an else block and so on. Probably it means that it's written by an Elm coder. Okay, the last part. So let me bring back the guarantees, and then let's move on from here. So this is what we look at it earlier. So let's suppose we have a scenario. So I wrote a post about this also. It's available online. So we have been told that a robust static type system can reduce the number of bugs in our application, transforming a 2 a.m. production issue into a red squiggly in our text editor. Okay, so we have something in JavaScript that is down here. So in this diagram, we have weak and strong type system, dynamic versus static type system. So JavaScript is, I don't know, more or less in this position. I download this from internet, so I'm sure it's very accurate. So the idea is that we want to move in a safer area like this. So I did create a small test with a small goal. So we want to create a function that take the last item of an array. So in this case, last will return the number 2, and here we'll return the string 2. And in case an array is empty, we'll return some kind of error. And in all those cases, we should have a warning at compile time. Okay, so this operation should be refused by the compiler. Those are the two functions. One is in JavaScript, one is in Elm. They're very similar. They just take the length of the array and they take the item at the position of length -1 in both cases. So let's see how the type are inferred. So in case of TypeScript, both the argument that goes in and the argument that goes out are considered any. Any for TypeScript means that the inferral engine basically gave up, so TypeScript cannot guess what the types are here. In case of Elm, we get a proper type annotation that says an array goes in, and as a return, we get a maybe that basically it says, yeah, I will return the same value that is contained inside the array, but maybe I also return a mistake because the array can be empty. So this is what basically we would like to get. So I tried a bit to improve the TypeScript version. So I came out with this middle version that I think it works pretty well. Someone was in the comment section of the post suggest me this version down here. I hope nobody's really using this one. It looks a bit crazy to me, but I don't know. I'm not very expert in TypeScript. Yeah, I will skip that one. So why there is this difference? Okay, why the TypeScript was not able to infer those types? So, Elm was designed from the ground up with the sound type system in mind, and so sound type system is a type system that is correct and is always infer all the types correct. TypeScript instead was designed not as a sound type system, because have the necessity to work on top of JavaScript. There was an interesting conversation about this. Some people was asking, if TypeScript, the fact of not being a sound type system was something that the community want to fix. And one of the maintainer of TypeScript answered that, well, first of all, soundness is not a design goal, and soundness, usability, and complexity form a trade-off triangle. So there is no such a thing as a sound, simple, and a useful type system. But I guess he was implying, remaining as a superset of JavaScript, because if you remove that constraint, I think it's possible to have a sound, simple, and useful type system, and Elm is an example of that. So to compare the two, again, one has a sound, the other has a not sound type system. So that means that Elm guarantees the type correctness without type annotation. At the same time, TypeScript, it doesn't guarantee type correctness and require type annotation. On the other side, Elm is not familiar to JavaScript developer. TypeScript, of course, is completely familiar to JavaScript developers because it's just the same, basically. And then basically, breaking free from JavaScript is what allow Elm to be sound. And the familiarity instead is what keep TypeScript to be a not sound type system. So going back to this trade-off. So the trade-off is between guarantees and familiarity. So technical decisions are always based on trade-off. This is one of them, and I think is an important one. So if you take the red pill, you embrace a world of guarantees, breaking free from JavaScript and learning a new paradigm where functions are poor, data is immutable, types are correct, and runtime exceptions don't exist. If you take the blue pill, you remain in the familiarity world of JavaScript. You have 25 years of back compatibility, and you can use TypeScript or other tool to mitigate JavaScript peculiarity. So at Rakuten, for some of our project, we took the red pill, and we are quite happy with the results so far. Okay, so this is all I got for you today, and thank you.
Yeah, thank you, Luca, for your great presentation. And let's start taking some questions from our audience. Anyone want to go first?
How you get the thing of the e-commerce symbol? Is it by designer?
The symbol of the e-commerce website, you mean?
The e-commerce symbol of the training side.
Wait a moment.